Hey, Evan.
Hello.
So do y'all have any questions while we're waiting for people to get in?
Uh, I mean, just a second. I have a question. I just need to see the assembly because there's like two parts that look like they're way too long on my assembly, and I don't know if I have the right measurements.
Uh, yeah, we don't actually know the measurements for the bike stand, so we're just kind
Okay,
of guessing.
got
So
it.
that's why. But I can check them with my dimensions to see if yours are correct if you want.
Sure. So for this, for these two, they just look a little too long for some reason. Like you see the
Yeah.
top point there, but I know that this measurement. Let's go in here and just. Where's the draw? Wow. Can't even find
You
measurement.
can just use the measure tool.
Where's the? Oh,
It's under
tools.
tools
Yeah.
and then measure.
Yeah.
It should be like 4.5 inches long.
Yeah, it's 6 inches. Oh, it's supposed to be 4.5.
Yeah.
Oh, I thought it
I
was 6.
Initially I had him as 6, but then I realized the same thing that you did, that it looks way too long, so I switched them.
Yeah.
Yeah, you gotta. Yeah,
Yeah.
so you can like kind of, yeah. So if you double click on a part, then you can kind of edit it inside of assembly, but that messes the assembly up. So what you gotta do is right click and then click open at the top.
Just open. Gotcha.
All right. Yep.
All right. Thank you.
Mm-hmm. Other than that, you're good. Hey, recently, do you have any questions about the CAD?
No, not really.
All right. So we'll wait until like 1:35. Jacob's supposed to be doing this first part while we finish, when we put those extra brackets on real quick.
Hey, so today I was thinking about like if it's okay with you, if everyone could like show up on the screen and we could take a screenshot so I can put it on the website for the summer training classes.
Mm-hmm.
Okay, cool.
Yeah, I mean, well, sure, I
a
guess.
camera.
Like if you're like if anyone is like comfortable with putting their like screen up and like I don't know, putting a
Oh,
thumb
yeah.
up. And then we could pull up something cool on CAD just to make it look like we're doing something cool. I mean, not to be like
I know what you mean.
okay, great.
I would, but I don't have a camera, so.
Yeah, I think we can just like try to do it at the end.
I was the same issue. I don't have a
Yeah.
camera either.
Okay, that's cool.
Chico. All right, so it's 1:35, so I guess Jacob forgot about it. So I'll just start doing it, and then he'll pick up once I leave off. So first, thanks to our sponsors, GPS, AXAXL, Griffith, and Vision Metals. So here's the bike stand, and turn the shadow so you guys can see it. So where we finished off yesterday was constraining these two brackets to the top right here. And these brackets are the exact same as these ones right here too, so this should be good. And then the next part, and these are all, remember, those are just flush and mate constraints. So we learned yesterday, not yesterday, Friday. So next what we're gonna do is make a bracket for this L right here. So the thing that we have to think about with this is where the bolts are gonna go. So basically, if we put, I kind of explained this last time, but if we put this L bracket right here, then one of the bolts will run into these bolts that are going down. So basically we just have to take out a hole from this bracket and then put it on. So to do that, Autodesk lets you copy and paste files just like if you're using a Word document. So we're going to go to Open, and basically just do Control-C and then Control-V. And I'll create L bracket 4 holes copy. And then we're just going to rename it to L bracket 3 holes. Open. And now we can basically go in here and we just want to knock out one of these holes. So each hole is a point, right? So the little green crosshair is called a point. Basically what we got to do is go to into the sketch, click on the point, and then just click delete, because that will delete the point and then the hole. Oh, important thing. So see how these dimensions are like dependent on these, remember from last time? So we wouldn't want to delete this hole, because then these dimensions would be dependent on nothing. And if you have a lot of those, it can mess up your CAD, and it's hard to follow if someone is trying to look at your CAD. So just click delete in your sketch. Now you have a 3-hole bracket. And we're going to go up here and click save. Next, we're going to go back into here and go to assemble and then place. And we're basically just going to put in the same the bracket that we just made. We need 2 of them. And then we're going to be using the constrain tool and then mate and flush. Let me see if Jacob is on there. There we go. Oh gosh. So, anyways, constraint from there. And so we want this face to be right here. So that would be a mate constraint. We need a flush constraint right here to the top of this. And now we've constrained it on 2 planes, the X and the Z. So it can move like that. So we got to do another mate constraint into right here. And now you'll know that it's good, because when you click on it and try to drag it around, it doesn't move anywhere. So that means that it's fully constrained. So then we're going to do the exact same thing on the other side for the other bracket. And
Is there a reason that you can only have 3 holes on that one?
yeah, so the reason it has 3 holes is because
Oh,
you have to think about where the bolt's going to go. So if you got a hole right here, and you have a bolt going through and a bolt coming down, then they would hit each other. So that's fun. All right, so now that we've got these, we are pretty good to go with the bracketing selection. So if you actually had a job as a person that was doing drafting for a company, you'd use this thing called the design accelerator and put all your bolts in. But in FRC, it's a kind of a smaller thing that we're doing. It's not like a whole business, so we don't put our bolts in because we only have like a week or two to CAD. So if we put up our bolts in, like, oh, we have to change the design, then it's kind of like we just wasted a few hours of our. So next thing we're going to do is the handle, and then we'll be pretty much done with this. So yes, so not yesterday, Friday, I realized that I kind of made a mistake with this. So in the actual CAD over here, you have, these are supposed to be 30 seconds of an inch thick. And the reason that is because you have to have room for this handle to be able to fit in between. So in real life, you would probably use 3/32 steel and make sure to make all this steel. Because if you have something that's under a lot of force like this, even on a robot, you would want to make sure it's steel and not aluminum, because aluminum can bend if it's doing this, oh no, if it's doing that over and over again. But usually on a robot, we don't have high stress environments like that, so we use aluminum. So I'm just going to go in here and edit these, right click and then open to edit this. And we're going to change the extrusions from 3. Alright, Jacob's about to get on. So now all of our little arms are 3/32 thick. So next what we're going to do is click update, and there we go. So, alright. Okay. So yes, I'll go ahead and CAD the first part of the handle and then take over. So for the handle, what we need to do is have, it's basically the same bar as these, and then we also are going to press fit probably a piece of wood or something into this so that it stays in. And a more like secure design would be this one, where it's basically 2 hollow pieces of metal and then a bolt right here. So, alright. Let's just start CADing the handle while we get this ready. So English standard, and we'll start a 2D sketch, and then it's going to be the exact same as the lift arm. So we're going to go over here and make this 0.5 thick and 8 inches long. So we're going to want a little bit longer handle. And then on one end of it, we're going to need the same arc that we did with the lift arms. And there we go. So see, we're good because it says that the sketch is fully constrained. So now we're going to extrude this the same 3/32 that we were using previously. Okay, and then I want this to be, we're using polished steel. And then we're gonna do the same hole right here, and both be 0.26. Autodesk usually saves the size hole that you need. It's just a helpful thing. So we're gonna go in here, go to the sketch inside of the hole, and we're gonna do the project geometry. And we're gonna use the point constraint. We'll constrain this point to the center of the arc so that it looks good. Because that's how we build it. And right there. Finish. now we have the main part of our camera. So we can go over here and then save that as okay. So I think, okay, so while we're waiting for Jacob, I'm going to show you. So in the FRC build season, we use this program that's kind of like GitHub, but it's called GrabCAD, and it basically lets us all work on the same assembly at the same time. And it's a pretty cool program. So what it does is you basically download on your computer, resend Alan and Matthew already have this, and it looks like this. So each GrabCAD folder, these are actual folders in my computer, and they're on the GrabCAD server. So what you do is you can upload files. So that's what I'm going to do right now. And then Jacob on his computer, it'll give him a little notification that says, John Stewart uploaded 4 files. And then he can download those files and work on them. So it's basically an easy way to upload and download files without having to copy and paste and delete them and send them in Google Drive. So that's our file system. But right now we're not using that because we don't want you guys to be CADing the same bike stand, because it's pretty easy. You know, usually the same person will be working on the same one subsystem. Like 2 people won't be working on the same subsystem at the same time, because Autodesk can get really confused if 2 people are editing the same file. And yeah, so okay. So basically, the next thing we're going to do is, in our handle, is just put a, oh, I'm sorry, I see. Is we're going to put a bar in the middle, so it goes like that, kind of like this here. And the way we do that in real life is we press fit a wooden dowel into it, and then probably put some super glue. But the interesting thing about this is that you can't put a, we want it to be even on both sides. So for that, we're going to use the mid-plane between 2 planes tool. And then right there, and right there. So we use that on Friday. So this just creates a 2D plane between the 2 sides of this. And how do you get to it by clicking on that? And next, we're going to start a 2D sketch on this plane. Oh my goodness. That was weird. Start a 2D sketch. And we're going to use the same object geometry. So you can click this right here. And then finish sketch. So now we have this circle on this plane. So we haven't used this yet, but on the extrude command, if you click that, see it'll say, oh, do you want to extrude it that way, like 4 inches? But we want to extrude it both ways. So we click on the arrow that has the symmetric arrow that extrudes it both directions. So let's say about, in real life, probably about 3 inches. So 3 inches means 3 inches on both sides, by the way. It's not 3 inches in total. And then, okay. So next, we can save it again, and then we're just going to put it in our assembly. So go back to the assembly and click place, handle, and then okay, Jacob Dane has entered the name. Okay, and then constrain it just like we did before, but again, we want it to be in between the 2 pieces evenly. So we're going to click on the center of the circle so you get that dotted line. And then we're going to constrain it to this so you get the same dotted line. So now it's right there. So now the handle can move in and out like that. So now we want to do a flush constraint because we want this plane to be flush with this plane. Because if it is, then that means it will be in the middle. Okay. So, oh wait, here, let me do that again so you guys can see that. That was Autodesk telling me this. So, if you ever get this constraint, this error message, you might be tempted to click on accept the relationship. If you do that, you'll have to, it'll really mess up your CAD. And it's really hard for people to edit your CAD, and sometimes it won't even let you open it if it gets really messed up. So instead, go back and try to do different constraints. We're going to try to do the mate constraint and see if that works. Because often, there we go. So often, depending on which direction the arrows are pointing in your constraint, your Autodesk will be able to choose whether it wants mate or flush. So next, so right now, our handle is kind of broken because it can just spin around this axis, you know. There's nothing stopping it. So what we have to do to make the full animation is go here to angle and then angle constraint. This is the very last constraint we'll probably do on this. And we'll pick our next project. So now it looks like it's a 0-degree angle, but we don't want a 0-degree angle because that's not really what it would be in real life. -20-degree angle. Fine. Now when you move, sorry, my computer's really slow because I'm doing zoom. But on your computer, if you pull down this handle, this thing should go up. So you can see it like that. There we go. That is a bike stand. So now I'm looking at it, the handle is kind of funny, but that's fine. So, yeah. All right, so the next thing we're going to do is switch over here, go down to here, and then we're going to pick out the project that we would like to CAD next. So I have some pictures of some CAD, and each one has different things that are good about it. So the work table on the left here is good because it's pretty easy. It's about as easy as the bike stand, and we can and it has a lot of the same skills that we're using in an actual FRC. This stand is a scissor lift stand, and we probably wouldn't be using hydraulics. We would probably be using a motor instead. But this one is also good because it has a lot of the same commands that we'll be using. But it's a good bit harder than the work table. And then these tires are pretty cool because, I mean, it's like a Lamborghini and a BMW tire. It's something that you would see in real life. And these also have a lot of the same commands that we would be using, but they're like way harder than something like these things. And then this, the Tesla Cybertruck, we could also CAD that. It's one of the easier cars to CAD because it has a lot of straight edges, not a lot of curves. So that one would be like the hardest out of all four, but it would also be most rewarding because it looks pretty cool. So just tell us in the chat what you want to, just like kind of like vote, you know, what you want to CAD in the chat. Okay, so we have lift, 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 lift. All right, and lifting rise up, which is like an extra lift. So it looks like we're going to be CADing a scissor lift. So it's about 2 o'clock, so we'll probably end this evening a little bit early. And yeah, on Wednesday we'll get started on CADing a scissor lift. Oh, and by the way, we're actually going to build the scissor lift. The other bike stand that we just CAD, we're probably not going to build. But if we did CAD a scissor lift, that actually worked pretty well. We would end up CADing something like it. So thanks for coming to this Zoom meeting, and see ya.
Wait, Jonathan, if we're building the scissor lift, does that mean we're gonna CAD it with motors, like you said?
Yeah, it'll It'll be very close to what we would actually be doing in FRC. Out of the four, that's the closest.
So we'd CAD it with motors rather than hydraulics.
That's what. Yeah.
Yeah.
So
But
go ahead.
I was just trying to figure out how never mind.
Oh, like how it would work?
Yeah.
Oh, you can just I'll send you a video. Someone building one. Send it in the group thing. All right. So we'll see you guys on Wednesday.